Yeah. So here the first once again quickly I will do recap. Here see there are total five equations, Maxwell's equations. Maxwell he did not write any equation. He has taken total five equations. The first equation C is Gauss law of electrostatics. Second equation is Gauss law of magnetostatics. Third equation is Faraday's law of electromagnetic induction. Fourth one is Ampere's circuit law, and the fifth one is Lorentz formula. These are the total. Actually, there are only four equations. This he added. They also added this also. These are the total. These are the equations of what you call Maxwell's equations. Next one, electromagnetic wave. If you look at the electromagnetic wave, this x, that is x-axis, is the direction that the light, when a light ray is coming towards you, then there are two planes perpendicular to each other. One, they are like two transverse waves perpendicular to each other. So electric plane is along y-axis, y plane, and along magnetic wave is along the z-axis. So, and this is the direction of propagation of the wave. This x is the direction of the propagation of the wave. So they both are perpendicular to each other. So coming to this one, see what he says. According to Maxwell, electromagnetic waves are those waves in which there are sinusoidal variation of electric and magnetic waves, magnetic field vectors at right angle to each other. So that is the reason he explained all this. Maxwell has explained electric and magnetic field, because in the four equations, one is the electric, the second one is magnetic, third is electromagnetic. It is in that way. So that's the reason he has explained all the four equations. Now they are perpendicular to each other. Here both electric and magnetic vary with time and space and have the same frequency. They both are having the same frequency. That means what? The electric plane and the magnetic plane, there are two waves, electric. So this transfer wave, when a transfer wave is given to you, it has both. When a transfer wave is given to you, it has a frequency and time period. What is the frequency? Number of oscillations made in 1 second. Number of oscillations made in 1 second is said to be frequency. And what is wavelength? Distance, the total distance of one wave. Okay, distance of one wave here, from here to here. Okay, length of one wave is said to be wavelength, and time period is time taken to complete one oscillation. One complete wave, okay, one complete pulse is said to be what? That is said to be the time period. So here what he says, both are having the same frequency. Okay, both electric plane and magnetic plane both are having the same frequency. Electromagnetic wave can propagate through the space with the speed of time, that is 3 into 10 to the power of 8 meter per second. Maxwell also found that electromagnetic wave should travel in free space with a speed given by c is equal to 1 by under root of c 1 by under root of so here he has given c is equal to 1 by square root of epsilon 0 and mu 0 and epsilon 0. This is the formula to calculate the speed of light. So speed of light, what is mu 0 here? Mu 0 is permeability of free space. Mu 0 is permeability of free space and epsilon 0 is permittivity of free space. Mu 0 is permeability of free space, epsilon 0 is permittivity of free space. Well, what is permeability? It is a property of the medium which allows magnetic lines of forces to pass through it. Coming to this one, what is epsilon 0? Epsilon 0 means it is a property of the medium which allows electric lines of forces. This is for electric lines of forces, this is for magnetic lines of forces. And the values are also given to you. Mu 0 value is also given to you, that is 4.5 into 10 to the power of minus 7 Weber per ampere meter, and epsilon 0 is 8.85 into 10 to the power of minus 12 Coulomb square per Newton meter square. Okay, and velocity of electromagnetic wave in medium is given by 1 by under root of mu and epsilon. Okay, so this is the thing. Next one is what? Next one is transverse nature of electromagnetic wave. Is this clear? Any doubt in the properties of electromagnetic wave? Any doubts? Yes. Yes. Anyone is having any doubt until this? Okay. Okay, no problem. See here, he says that Okay. Okay. Now see, Maxwell, you know that about the Maxwell's equation. These are the total 5 equations. Okay, Maxwell's equations. These are the total 5 equations. But this is not there in our syllabus. So now from here we have electromagnetic wave. So according to Maxwell, electromagnetic waves are those waves in which there are sinusoidal variation of electric and magnetic field right angle to each other. Means there is a electric wave and there is a magnetic wave, both are perpendicular to each other. Electric wave and magnetic wave both are perpendicular to each other, and along x-axis is the direction of propagation of the wave. Both these fields, okay, they have the same frequency. Both electric and magnetic both are having the same frequency. Is that clear? Electric plane and magnetic plane or magnetic wave are having the same frequency, and speed of electromagnetic wave is how much? It is equal to speed of light, which is equal to 3 into 10 to the power of 8 meter per second. And also, how to calculate the speed of light? Because we are using electric plane and electric wave and magnetic wave in the formation of electromagnetic wave, then the formula is given by C is equal to 1 by under root of mu 0 into epsilon 0, where mu 0 is permeability of free space and epsilon 0 is permittivity of free space. Permeability means it is the property of the medium, which is a property of the medium which allows magnetic lines of forces to pass through it. And what is epsilon 0? It is a property of the medium which allows uh, electric lines of forces to pass through it. And what is the value of mu 0? Mu 0 is 4 pi into 10 to the power of minus 7 Weber per ampere meter. Epsilon 0 is 8.85 into 10 to the power of minus 12 Coulomb square per Newton meter square. Okay. So the velocity of electromagnetic wave is given by 1 by under root of mu 0, mu and epsilon 0. If it is in the medium, if this is in the space, mu 0, epsilon 0, if it is in the space, and if it is not in the space, if it is in any medium, then we use 1 by mu and epsilon. Any doubt in this? Yes, is it clear, all of you? Yes, please. Is it clear, all of you? Okay, I'm going ahead then. Chalo. So now here transverse nature of electromagnetic wave. So we have taken a cube here, like ABCD is a cube, and ABCD and OEFG, these are the two faces, both are parallel to each other. Two faces or two planes, you can say, both are parallel to each other. Now here he says, what is that? According to the Gauss law of electrostatics, we have closed integral E dot ds equal to 0. Gauss law of Gauss law of electrostatics, it is q by epsilon 0 actually. The formula is closed integral E dot ds is q by epsilon 0. So if the rectangular parallel pipe does not enclose any charge, if it is not enclosing any charge, if it doesn't have any charge, the total electric flux is how much? Because q is equal to 0, the total value will be 0. Q by epsilon 0, the total value will become 0. Understood? So now E does not depend on Y and Z. Therefore, the contribution to the total electric flux coming from the faces normal to Y and Z will cancel out. So there is no charge, so the total answer will be 0. Okay, so this is not required. Now, how to, here. It means electric field is perpendicular to direction of propagation of the electromagnetic wave. Similar argument holds that true for magnetic field. So electric and magnetic field are transverse in nature, and they are perpendicular to each other. Is it clear? Is this clear? Okay. Then going ahead with the next one, that is propagation of electromagnetic wave. How do we produce electromagnetic wave? Let us first see whether it is there in the syllabus or not. See, if you look at this one, what he says, the characteristic, their transverse nature. He did not discuss about the production of electromagnetic waves. Only production of electromagnetic waves he is not asking. He speaks about transverse nature of electromagnetic wave. Then properties of nature of electromagnetic wave. Okay, only these two properties are required. Now, so we will not go with this. Okay, now, so we'll discuss directly the properties of electromagnetic wave here. What are the properties of electromagnetic wave? They are produced by the accelerated or oscillating charge. Okay, they are produced by the accelerated or oscillating charge. When the charges are oscillating, then we get a electromagnetic wave. So what is happening in the antenna? When the charge, suppose what happens, see here, this is the antenna. When the charge in this antenna accelerates, when the charge in the antenna accelerates, then what happens? Electromagnetic wave is produced. Okay, electromagnetic wave is produced. Now, so electromagnetic wave do not require any material medium for propagation. It can travel in space. It doesn't require any medium. Electromagnetic waves do not require any medium for the propagation of the wave. These waves travel in free space with a speed 3 into 10 to the power of 8 meter per second and is given by the relation c is equal to 1 by mu 0 into epsilon 0. Okay, the speed of the light is how much? These waves travel in free space with a speed that is 3 into 10 to the power of 8 meter per second, and it is given by the relation c is equal to under root of mu 0 into epsilon 0. And now there is one more way to find out the speed of light. What is that? The one more way to find out the speed of light. In electromagnetic wave, the sinusoidal variation in both electric and magnetic field vectors occur simultaneously. As a result, they attain the maximum and minimum values at the same place and at the same time. What is the meaning of same time and same space? Go back. See here, if you look at this, if you look at this point, see here, the amplitude of electric wave and the amplitude of the magnetic wave, they both are taking place at the same time and at the same place, or same time and same place. See here, this and this one, this and this one, both are, even though they are in the two different planes, even then also the electric and magnetic amplitude of electric and magnetic plane is taking place at the same point and same place. The amplitude of electric plane field and magnetic field in free space are related by c is equal to E0 by B0. What is By here? Magnetic field along y-axis is given by B0 sine omega t plus kx plus omega t. This we studied last year. In last year grade 11, we wrote the equation of the wave y of x comma t equal to what? A sine kx minus omega t. Do you remember? Or kx plus omega t. Where k is what? K is propagation constant. Where k is propagation constant. Okay, the value of k is how much? K equal to 2 pi by lambda. And what is omega? Omega equal to 2 pi by t. Okay, or omega equal to 2 pi nu. This is the formula for omega. Understood? So we have k is equal to 2 pi by lambda and omega is equal to 2 pi by t or 2 pi nu. So direction of variation of the same way. So same equation we are writing this, using this equation we are writing By. That is because why? Because magnetic field is lying along y-axis. So an electric field or electric plane is lying along z-axis. So therefore we write By equal to B0 sine kx plus omega t, and similarly Ez equal to E0 sine kx plus omega t, where B0 is the magnitude or amplitude of the magnetic wave and E0 is the amplitude of the electric wave. The direction of variation of electromagnetic wave, electric and magnetic field vectors are perpendicular to each other as well as perpendicular to the direction of propagation of the wave. And electromagnetic waves are transverse in nature like light waves. Okay. Next is what? Electromagnetic waves carry energy which is divided equally between electric field and magnetic field vectors. Okay, they are electromagnetic waves carry energy which is divided equally between electric field and magnetic field vectors. Now come to this point. The next point. Now, what he says, in vacuum, the average electric energy density and average magnetic field density, energy density, okay, due to static electric field and magnetic field, which do not vary with time, are given by this formula. This is the average, this is what average that is electric and density, energy density of electric field, energy density of magnetic field. Both are given by half into E0 into E square and half into B0 by mu 0, B square by mu 0. These are the formula for magnetic energy density and electric energy density. The electric vector is responsible for the optical effect of an electric wave and is called light vector. The electromagnetic waves, being uncharged, are not deflected by electric and magnetic fields. They are not deflected. Electromagnetic waves being uncharged, they don't have any charge, are not deflected by electric and magnetic field. And the velocity of electromagnetic wave in dielectric is less than speed of light, that is 3 into 10 to the power of 8 meter per second. Is it clear, all of you? These are all the properties of electromagnetic wave. Is it clear? Yes, Mr. Sayyam and Joan, are you clear with this? Okay, then going ahead, what is the next one? The magnetic field in a plane. The magnetic field in a plane electromagnetic wave is given by this equation. How do we solve this question? See here, he is asking to find out the wavelength, frequency, and the same equation in he has given the equation in terms of magnetic field 2 into 10 to the power of minus 7 sine, the equation of wave is given as sine of 0.5 into 10 to the power of minus 3 x plus 1.5 into 10 to the power of 11 t Tesla. He has given like this, t for Tesla. So it is in the form of what? By is equal to what? B0 sine kx plus omega t. This is the equation. What is B0? B0 equal to 2 into 10 to the power of minus 7. What is k? K is what? K is equal to 0.5 into 10 to the power of minus 3. That is equal to 2 pi by lambda. Okay. And what is omega? Omega is equal to how much? 1.5 into 10 to the power of 11. That is equal to 2 pi. We can write 2 pi nu or 2 pi by t. Okay, this value is 2 pi by t. Is it clear? Now? Now. Here k is equal to what? 0.5 into 10 power minus 3. And omega value is 1.5 into this value. Because we are equating, this equation can be written as By is equal to how much? We can write here as B0 sine 2 pi by lambda into x plus 2 pi by t into small t. We can write in this way. So what I can write here now? I want wavelength. So what he is asking what is wavelength, what is frequency, and what is the same equation in electric wave. Okay, Ez equal to how much? Now we can also write this as 2 pi. We can also write 2 pi nu. So I'm just solving this equation. See here, lambda is equal to how much? Lambda is equal to 2 pi by 0.5 into 10 to the power of minus 3. Just solve it, you will get the answer. Similarly, what is he asking? He is asking frequency. Frequency is equal to how much? 1.5 into 10 to the power of 11 by 2 pi. Is it clear? Is it just you have to solve these two values? Nu is equal to, you will get this one. So how will you solve this? 2 pi is equal to how much? 2 into 3.14. Just solve it, you will get the answer. So answer is coming around 1.26 into 10 to the power of minus 2 meters, and this value is coming around 2.39 into 10 to the power of 10 hertz. Is it clear, all of you? Yes sir. Is it clear? Yes, Ibad. Juan and Sayam. Are you clear with this? Okay, then, so this is about the equation. Once again, see here, this equation is given to you. Then we are writing this equation is in the form of by is equal to b0 sine kx plus omega t. b0 value is given to you. We want to find out what is k. K is equal to this value 0.5 into 10 power minus 3, that is 2 pi by lambda. Omega value is 1.5 into 10 to the power of 11, that is equal to 2 pi by t, which is equal to 2 pi nu. Then equate this value here, lambda is equal to this much, and new value is here, equate. Just cross multiply, you will get the answer. Last one is what? We have to write Ey. What is the formula? Ez equal to E0 into sine. Sine, again same way you have to write 2 pi x by lambda plus 2 pi by t into small t. You have to write this equation in this form. Then what is E0 here? Because we told in the properties or the characteristics that E0, amplitude of the magnetic field and the amplitude of the electric field both remain the same. So we can just write as it is. And we have lambda with us. Just substitute the lambda value here. And then in the place of t, just substitute the value and simplify. You will get this answer. See here, we are writing everything is same. Only E0 also, you see how to calculate E0? C into B0. You just write that one.